In this video, we will talk about potential energy of a body. For contents like this, subscribe and let me know the topic you want to study next. Potential energy is the energy of a body because of its position. When you bring a body from a lower level to higher level, or from a lower height to a greater height, that body will have some potential energy. Let's take this example. You have a 5 kg mass at point A and you have to bring it at point B, which is at a height. Let's say this height is 10 meters. Now, to bring this body from A to B, you will have to do some work. Work, if you remember, is in joules. You do some work on this body and bring it at point B. Now in the process, since the height of the body has changed, it went from a lower level to higher level. At height B, the body will have potential energy. The formula for potential energy is mgh. M is the mass, g is acceleration due to gravity, which is 9.8 meters per second square. H is the height. Here we have the mass as 5 kg. Let's write the given information. And the height is 10 meters. The potential energy at point B would be given by this. All we do is plug in the numbers. So we have the potential energy at B as mass, which is 5, g 9.8 times h, which is 10. It should be 490 joules. It's actually that simple. Let's see another example. You have a 12 kg mass at point A. You are bringing it to point B. When it goes to point B, it is at a height. We are trying to find the potential energy of the body at point B. Now see this angle 30 degrees and this is 6 meters. The formula is mgh, but this is not your height. The height is always the perpendicular distance. So the height from A to B, from point A to B, is this one, h. In this problem, we don't know what h is. So before applying the formula mgh, we need to find out all the information. We have m as 12 kg. We don't know the h. G of course is 9.8. So let's try to find out h. If you notice, this is a right triangle and we know this angle and we know the length of the hypotenuse. So we can say that sine of the angle 30 degrees would be the length of this side, which is h, which is also the height, over the hypotenuse, which is 6. Sine 30 is 0.5 equals h over 6. So 6 times 0.5 is the height. 6 times 0.5 is 3. So height is 3 meters. And now the potential energy at B would be mgh. M is 12, g is 9.8 and h is 3, which comes out to be 352.8 joules. So in cases where you have the hypotenuse and the angle given, you will use trigonometry to find the actual height and then use the height in the formula of potential energy. If you understand these examples, can you try this problem? You are trying to bring the body which has a mass of 20 kg from point A to point B. Calculate the potential energy that you will have at point B and comment your answer below.